Okay, so our first topic we're going to do this year is a matrices. So a matrix is a rectangular array of numbers or pronumerals. So remember, pronumerals are like the letters, and which are called elements, which are enclosed in square brackets. So what we mean is we might have these square brackets, and then we have numbers or letters within these square brackets. So what we're saying is that each of these are called elements. So this matrix here actually has 6 elements. So this is what a matrix, we contain information in these square brackets. So one of the most important things that we need to know about a matrix is its order. Now its order is like telling us its shape or dimension or size or whatever of the matrix. And we often see it written as if you look here, a number times a number. And so we've just summarized and we've said m times n. Okay, so the first number that you're told are the rows. So this first number in the order is the rows, and the second number in the order is the columns. So say for my example I just drew up here, so this one's got row 1 and there's row 2, and here's column 1, column 2 and column 3. So this one's order would be a 2 by 3. If you look down here on our example here, we have matrix A. So that was another thing I didn't mention. Matrices are often labelled with a capital letter. So this one we're calling matrix A. Okay, this one's order has 3 rows and 2 columns. So that's why it's a 3 by 2. And it has 6 elements. But so does our other 2 by 3. So we can have a matrix. So now we know we can get this matrix. So say for that we have that example here that we've got that matrix A, and we want to, and we know it's got 6 elements, but sometimes they want you to find in the matrix a certain element. So when they want you to find a certain element, they will ask you by using this type of coding or language. So they use little a because the matrix is labelled with a capital A. So when I see little a, I know they want me to go to the element. And you can see that they're saying they'll give a number in this first spot, and here we've just replicated with I. So I actually equals the row number they want you to go to, and J will indicate the column number they want you to go to. So for this example, when they said A32, they want you to go to row 3 and column 2. So if you look in this matrix A, row 3 is along here. Here's row 3, and column 2 is along there. So they want you to tell you that number, so you can say, all right, that's -4 is the one they're after. So sometimes we'll see, mainly next year when you're doing year 12, you'll see they use this I and J description in terms of here. So then where they will always say that I equals the row number and J equals the column number. So they just they always refer to it like that. So they were just saying, so that just means if they write little m 2 3, that means they want me to go to row 2 and column 3. So they want me to go to 5. Okay, so they'll just indicate it using the letters I and J. So what we have in this exam question is that they have given us a matrix M here, and we can see this M is a 2 by 4. Okay, and they're saying that one of these rules down here, these rules will produce matrix A if you use it. Okay, or matrix N, sorry, if you use it. So what we're going to do is we're going to test it out. So this is, I'm going to test answer A first. Okay, so I'm looking at this rule here. So the rule says that if I'm trying to fill in the matrix, so over here, I would have a 2 by 4. So what I'm going to have is 1, 2, 3, 4, 1, 2, 3. So I'm going to put in those 8 answers. And they're telling me the rule to work out those elements is to do I plus j minus 1. So remember, I means the row number. So I equals 1 here, and I equals 2 along here, and j equals 1 and j equals 2 because j is the column, and j equals 4. Okay, so what we're saying, if I was, say for example, I'm going to find out what this element is, I would use this formula. So we're saying that you find the formula by going I, so I is 2 in this case, plus j, which is 1, minus 1. So if we do that, 2 plus 1 is 3, minus 1 is 2. So you can see we get 2. Now 2 is not in our original one, so I know that's not the answer, so I'll go and try the next one. So I'll try B, where the formula is saying that it's 2i plus j minus 1. So let's have a look at that one. So as soon as you get a wrong one, you move on. But if they're all right, we have to keep checking, make sure they're all right. So this would have the 4 again, and we know that, so let's have a look. So we know this is I equals 1, I equals 2 here, and j equals 1, j equals 2, 3, and j equals 4. So let's have a look. So if I was doing, I'm just going to do this one again because there's room. All right, so it'd be 2 times I. So I in that spot is 2. So it's 2 times 2 plus j, which is 1, minus 1. So that'd be 4 plus 1, which is 5, minus 1 is 4. So that already isn't, we want it to be 3. So that's not the answer. So then let's go test C. So C's formula is saying that you do 2 times I plus j and you minus 2. Okay, so we would have this matrix here with the 8 elements missing. So remember, I equals 1 here, I equals 2 here, j1, j equals 2, and j equals 4 in that spot. Alright, so if let's go and I'll just do our bottom one, we're getting used to doing that. So it's 2 times I again, which is 2, plus j, which is 1, minus 2. Now that would be, when you saw that would be 4, plus 1 is 5, minus 2 is 3. Now that's good, that's what they have up there in the answer. So then I'd want to go check all the rest. So if I check this one, it'll still be 2 times 2, plus, now it'll be plus 2 and minus 2. So that ends up being 4. And you can see that gives the answer that we've got up there. So if you go and you check all of them, you're going to find that you are going to get the answers, all the right answers. So we'll just double check this one to have a look to practice. So it would be 2 times I, which is 1, plus j, which is 1, minus 2. So that ends up being 1, which you can see is also up there. All right, so if you check that out, you'll see C is the answer. So we're going to go with C. Okay, this question is a little bit difficult and it is taken from a year 12, but just why we're learning about, row number and column number spot. You can do this question, so I wanted to show you so that you can get familiar with it and hopefully makes it a bit easier for you in your year 12 year. Okay, with matrix C, that shows the number of men and women working in 3 different department stores. So we're going to be given matrices now, which shows data or, information. And what they're going to do is they're going to prompt you to see if you can interpret the information by asking you questions about this matrix. So you can see the first question is asking us, what is the order of matrix C? So you can see the order of matrix C is we have 3 rows and 2 columns. So here's the column 1, column 2, and row 1, 2, 3. Okay, what information is given by the element C21? So that means we go to matrix C, which is, there's only one matrix. That means we go to row 2 and column 1. So if you go to row 2, column 1, it's 11. Now it's not asking us what's the number, it says what information. And so we would say that there's 11 men in the legal department. Okay, so it's telling us what information is it telling us, so we better write what we've got. It's telling us there's 11 men in a legal department. Okay, so in the next question, it's asking us which element gives the number of men in sales. So if you go to men in sales, that's here, that's 62. So they want you to label it with the coding. So we're in matrix C and we need to go to row 3 and column 1. So we'll see a C31 to get the men in sales. And then the last question, it's how many women work in the 3 departments in total. So we want to just, if we look for the women, we just want to add up all those numbers. So we would add up those numbers and we get 91 women. Okay, so now we have, we know what matrices are. We can have different types of matrices. So you can see here, when we have a row matrix, it's just simply one row. So all the numbers, and you'll see that there's a 1 in the order. So it'll always be a 1 by something if it's a row matrix. If we have a column matrix, so you can see with the column, we just have one column. So it'll always be something by one column, by 1 for a column matrix. Now with a square matrix, we have the same amount of rows as columns. So you can see this one here has an order of 2 by 2. So if I have a 3 by 3, and I'm just making one up, so that is also a square matrix. So the rows equal the columns. Now, if you'll see here on a diagonal matrix, we have numbers on the leading diagonal. So with a diagonal matrix, it must be square as well. So you might write a note, it's a square matrix. And if you look at this one is a 4 by 4. So for it to be a diagonal, you'll see numbers only on the, non-zero numbers, on the leading diagonal. Now the leading diagonal must start up here in the left-hand corner. So diagonal starts up here. So let's write that in. So it starts up here and then goes down to there. Okay, so and you can see there's zeros everywhere else. Okay, if you have an identity matrix, this is another square matrix, and so this one you can see is a 3 by 3. It doesn't have to be a 3 by 3, so it just has to be square. So I could have a 1 by 1. So if I draw a 1 by 1 identity matrix, you've got it there. You can see what makes an identity matrix is that on that leading diagonal, there is only ones. So the leading diagonal has have only ones, okay, and zeros everywhere else. So we'll learn about the identity a bit more and how it becomes useful. So a null matrix has just 0 zeros, and we only say that two matrices are the same if they are exactly the same. So that means if I put that like that, it has to be exactly. So the x has to be in the exact same spot for them to be equal. So they won't be equal if they're, even if the elements are the same but in different positions, it's not the same. All right, so a quick summary. We know that a matrix has the square bracket. So, you know, like that. That's a 1 by 1. So we know that would be a square matrix. We know the order is we do the rows by columns. So if I had, for example, this one, we do 1 row by 3. Okay, this one is also a row matrix. A column matrix has just 1 column, so we might see it like that. So this one's order would be a 2 by 1, and we've already talked about a square. Okay, so this one is just talking about, we're going to use an example of showing how we can put data and make it into a matrix and or display it. So the first thing it says, construct a matrix to display the information. So pretty much all you have to do is put the numbers inside square brackets and in the rows and columns. So we're gonna just pretty much copying the table but into a matrix form. What is the order of this one? It's got 3 rows and 3 columns, so it's a 3 by 3, another square. Now it says construct a row matrix for relating to household B. So B, and they want the information. So we would, a row matrix just has 1 row and write the order, so it's 1 by 3. Then it asks us to construct a column matrix of the numerical info relating to computers. So that would be this data. So if I write a column, what is the order? That one's a 3 by 1. And what does the sum of the elements? So just really important that you remember that this word sum means you plus it, you add them all together. So if we add them all together, what is that telling us? Which would be 4. So what does the sum of the elements tell you? It tells us the total amount of computers in these households, these houses. Okay, so they're just making sure that you can interpret it. All right, you're gonna go off and do exercise 4A of the textbook, and we're doing all the questions.